When talking about smart grids and the problem that they are trying to solve, a similar problem is what we were mentioning yesterday. This is the problem that cloud computing is trying to solve, which is that of varying demand. Okay, so when you have a set capacity which is at a static data center, when the demand is changing, the difference here is the unused resources. Okay, so the demand could be very, very high, as we said, for example, at Boxing Day. During that time, the unused resources are very small. During all the other times, when the demand is smaller, then the unused resources are really big. And cloud computing resolves that by renting resources, by using cloud resources whenever you need it. Whenever the demand goes up, you increase the resources. Whenever the demand goes down, you decrease the resources. Okay? So the issue in smart grids is the same. It's the same problem. So let's jump to that. Okay, so I asked you to work on trying to figure out what is the problem that, or the problems that smart grids are trying to solve, how are they trying to solve them, and what are the components that are needed. So first of all, I'm going to mention some of the drivers of smart grids, then go and define the different components. One of the major issues is that the cost of fossil fuel energy is pretty expensive. And trying to generate electricity using fossil fuel costs a lot of money. So at the beginning, in the 1970s, 1980s, gas, coal, and oil were thought to be abundant, infinite resources. However, with population growth, with growth in our usage of these resources, you've had also a huge demand on these, and you have price increases that have made this unstable. Okay. If you have and one of the other things is such electricity generation is limited by particular government or similar to government corporations, and they're the only players. It's usually a monopoly, right? So they can charge whatever they want. So if you have a liberal market instead, if you have multiple utility companies, then they would be obliged to have competition between them and to do innovation, which would lower the prices. Now they can't do that. The OPEC, which is the group of the countries which generate fuel, they decide on the prices together, the prices of fuel together, and that basically changes our daily lives and our electricity prices. Now, the other thing is that we have to think about is energy security and availability. We want to make sure that it's reliable, it's available. When we have a flood, we're not ending up losing electricity for 2 days. Ensuring capacity and minimizing outages, so those are important. And some of the environmental factors. So power generation is creating most of the CO2 emissions, so we need to reduce that, and it's also leading to climate change. Now, so these are the drivers of smart grids. In terms of the actual definition, formally, smart grids are integrating different devices that used to exist in power grids. So power system apparatus, the power electronic switches and routers, all the sensing and monitoring technologies, and also information technologies and communication, so ICT. And it's doing that to solve this problem, the main problem, similar to cloud computing. So improving grid performance, especially the generation to load ratio problem. So the generation is the capacity, and the load is the demand. Okay? That's just the terms are different in energy systems. And when the generation or the capacity is high and the load is low, then that ratio is high. So the unused resources are a lot. So what we want to do, similar to cloud computing, is to reduce that ratio, which means it reduce that difference, reduce the unused resources. Now, this will also lead to minimizing environmental adverse effects, enable at the same time interaction between different customers depending on their demand, and power producers could actually compete to get different customers, and also create mechanisms that would solve the problems, so self-healing and automated solutions to solve the power disruptions. So as we said, it's in cloud computing, we don't want our transactions to stop. We don't want disruptions. In the same way, we don't want disruptions in the power systems because they lead to also lots of loss of money. That's why we want the systems to heal themselves to solve the issues that they have. So let me just explain a bit more about this. An additional reason why this is a very big problem for smart grids is the cost of producing the generation. So the cost of the generation. For example, in Canada, the cheaper ways of producing electricity are wind and water and nuclear, I think. So they go in that order, from what I can remember. And that's what you produce at the beginning, okay, when the demand is low. When the demand goes higher, you go into coal. And when the demand goes even higher, you go into gas and fuel. So, and the price goes up for each of these, okay? So the demand basically has a peak, has a huge peak. During that peak, you have to use all of these, and your price goes up. If we normalize this, if the demand is normalized, then we wouldn't be using some of those dirty technologies, dirty in the means of the ones that hurt the environment, plus they also cost more. So if the demand is normalized across the day, for example, we'd be just using wind, water, and nuclear, and they would be enough, and we wouldn't have this problem, okay? So again, similar to cloud computing, we have this varying demand. Based on that varying demand, we have an additional problem of during those high peaks, we're obliged to produce through means which are far more expensive. That is also increasing the prices on everyone and leading to massive CO2 emissions. Okay, so the different components that you need, again, you can think of it from a smart infrastructure perspective. So you're going to be needing smart meters. And I'm going to explain each of these in a bit. Voltage or phasor measurement. So these are sensors. Communication mechanism to transfer this information. Distributed feeders or generators. And this is in a chart where they would go. Let's see. So for data integration, let's start from the bottom. So you have generation plants. Then you have distribution centers. Then we would like to have places to actually, let's see, store some of the power that we're generating, if we can, especially the one that we've generated at low cost. You also have integrated communications. You want all of these to be able to communicate together in real time. Plus, the data that's coming out, and one of the groups was mentioning this, forecasts based on historical data of people's usage, okay? And you do real-time optimization based on that, and you can optimize how you're using your resources, how you're generating, distributing, and where you're sending that, that power. Now, okay, so this is the order. Okay, so let's go to the specific components now. So smart meters. What is the role of smart meters? um, the smart meters are supposed to change, are supposed to be replacing the original devices, the electric meters that we had. They would measure the detailed consumption within the home. They would be connected to several smart appliances at home. And it relays this information to the system. It enables people to adapt their consumption based on time of use pricing. So even now we have the price that you pay for using electricity after midnight is cheaper than what it is during the day. Okay? One of the reasons for that is the utility companies are trying to encourage people to turn on their washing machines, let's say, after midnight, rather than after coming home, because if everyone does that, then again you have that peak. Okay? So the goal is reduces peak usage periods, could interact with smart appliances, and by interact we mean it can automatically, based on the lower cost of the time period, turn on your, let's say, washing machine or dishwasher and things like that, even when you're not home, or when you're sleeping. So some of the issues here are what degree of control can be given to the utility, what social or pricing incentives are effective. Okay? How can you convince people to not turn on their washing machine until they're sleeping, let's say? Some of the other elements, these are just a few slides from Professor Reza Iravani, who's in the energy systems in electrical and computer engineering. So conventional distributed feeders, this is the way you generate and basically send electricity. So typically, you generate electricity at a very high voltage. Then when you send them to distribution centers, the voltage goes down a bit. And then the closer you get to your home, the voltage, the power gets transmitted at a lower voltage, and you see thinner wires basically closer to your home. So one of the main issues now is all of this mechanism is one way, is unidirectional. So the power that you generate and you distribute and you send, you can't take it back. If that's not used, it's not used, it's wasted. Okay? And the other thing is these loads are not connected to each other. So even if I send something here, I can't go back and send it somewhere else. So disconnected and de-energized. Now, with microgrids, which are one of the components of smart grids, a microgrid is a cluster of these distributed generation and distributed storage devices that can be connected in these different modes. So grid-connected mode means all of them are connected with each other. And in the islanded autonomous mode, so this means it can heal itself whenever it has issues, and a transition between the two. So this is how a microgrid would look like. You have different types of generation centers that they're distributed, and you can turn them on and off whenever you need them based on the different load in different places. Plus, transferring electricity from place to place also loses energy. So it's always better to produce something closer to where the load is. So an intelligent microgrid will be able to use the data from what I called previously is phasor measurements or voltage measurements. So this would detect how much the demand is in different places. This is on the wires. Other than using smart grids at home that would collect this information. And using ICT, using sensing and communication technologies, it enables bidirectional power flow with the main grid. Okay? So it solves that problem of you have one way, and if that power isn't used, then it's wasted. And it also creates a more resilient, decentralized infrastructure. You're not limited to that one direction. If there are problems occurring in different areas, they can solve their own problem. by basically, if you have additional storage, then from the storage you send that additional power. Or if you have a different distributed generator, then that generator will generate electricity in place. So this is what it would look like. So you would have all of these being bidirectional, and depending on the power usage, you could generate closer to the destination. And you also have storage in place. Okay? And this is the view of how a microgrid would look. And you can have lots of these connected to each other, similar to basically the internet, pieces of the internet connected to each other. And you can have mega versions of these. So this is working as the building block of the smart grid. And you can have cities, so wide area smart grids, having this like connectivity, and you can, based on the usage that you need, you can send electricity from a place to a place. Okay, so I think, let's see. Okay, so I have a few more slides about the benefits of smart grids. So efficiency in this distribution and management of the energy. Reliability, so you have a reliable system. If you have issues that are happening in a zone, you don't have to wait for like a day or two for someone to go fix it. You have additional electricity that gets supplied to you through a different line. Environmental benefits, because you're reducing the high peaks and you're reducing the waste that you're having with energy. Okay, so you're going to work on that in the afternoon. But now I'm going to give you another small activity to work on. First of all, do you have any questions about smart grids? What are some of the things that I missed in my slides based on what you came up with? What are some of the components you came up with? What are some of the additional problems that you're perceiving being solved? Sorry? Workforce?
Yeah. So
how would it affect it?
You don't need as many people to manage it?
Yes. So you won't, the maintenance of power lines, it's a big issue. You do still need people to manage it. However, it's far faster. So now that you have those phaser sensors on the lines, you know within like 200 feet where the problem is. You don't need to go and like guess and check different places. And in a lot of the places which are growing or new cities that are being built, not in here, in different parts of the world, they're putting smart grids, and it's solving a lot of these issues. You know right away where to start to solve the problem.